Thanks.
Thank you so much. So yeah, it's great to be here, and today I will talk about orchestrating LLM inference with Apache Airflow. But before I start, a little introduction also from myself. So my name is Volker, which is a German name, by the way. So we moved to the US a year ago, kind of. And also a little bit about myself. I have 2 kids, and yes, I'm missing them right now. And also I'm doing a lot of photography and videography, and I like to go to the gym and think about my next side quest. So I love side quests. You will see that during the talk. About my professional background, so I'm coming actually from the gaming industry. So I was a data engineer in the gaming industry for almost 15 years, which was quite exciting. And as said, now I'm working for Astronomer and create content all around Airflow, AI, and orchestration. A few fun facts. So I built a Minecraft plugin, actually. I guess you all are familiar with Minecraft, or have heard it at least, that lets you build data pipelines within Minecraft, and they are then translated to Airflow decks. If you're interested, you can check out my LinkedIn. I have a video about it. I also created some other fun side quests, so just check it out. And I'm also volunteering for Data Engineer Things. So for me, it's a pleasure to be here on stage because it's a great community, and I'm super happy that we have this conference. And that should be enough about me. Now, I have a question to you, actually. So this is some code I don't need to explain. It's just basic LLM inference, super simple. We get some kind of reply, we send it to the customer, and that's it, right? Do you think this is fine, or is there something missing from your perspective? Anything? Anyone brave enough to speak up and say what might be missing? Yeah? So like an abstraction layer, kind of. Okay. Anything else? What do you think might be missing? If not, I can. Okay, go for it. Nice, perfect. Very good. I mean, I can also rephrase it. By show of hands, who of you thinks this is not yet ready for production? Okay, that's good. That's good. I tell you why. Because first of all, resilience, so error handling. What if something goes wrong? What if there's a timeout? Also validation. I mean, we just assume that what comes back is what we expect, right? But we don't validate it. Also approval. I mean, the customer might be a VIP. I mean, every customer is a VIP, but maybe we want to have someone like approving what we send to our customer, right? And then also observability. We might want to learn about this, what happens, what is the output, some logging. So kind of an abstraction layer, that's true. We need something more around it. And I would like you to keep those in mind because you will see these topics more often. Now, before I jump into the content, I have a little story to share. So now it's story time. And we have to go back over a decade actually. So back then I was working as a data engineer, and we also had a data science team. And what they did, they created a machine learning project, a prototype, in a notebook, and I was doing like churn prediction. So what that means, back then I was in the gaming industry, so we wanted to know if players that played our game will stop playing the game in 2 weeks, in 4 weeks, whatsoever. That was all fine, and then they gave it to us as data engineers and said, hey, can you put this into production? And we said, yeah, easy, let's do it. And then 1 month later, they were asking, hey, where's our machine learning project? Why is it not done yet? Because the code was ready, right? Why does it take you over months to put it into production? And it caused a lot of tension. We had a lot of meetings, you know how it goes. And then I also went to some conferences, and back then there was this paper called Hidden Technical Debt in Machine Learning Systems. And I wonder, does any one of you know this paper just by show of hands or have heard about it? Yes, very good. So this actually is pretty cool because back then at the conferences, you have seen kind of this picture a lot. Not in this form, that's a recreation of it. But when I saw it the first time at the conference, I was like, yes, that's the reason why it took so long. I took some photos, I sent it to Slack and said, you see, that's why it took us so long. And then I was happy, of course. But I was thinking about this picture a lot because you can also translate it to the current AI situation, because the model is just a small fraction of the whole production system. There's a lot of stuff around it. And the same is true for LLM inference. So the model in the center is just a very tiny part. It's an amazing part. I mean, these teams do crazy things. We have OpenAI outside, and it's amazing what they create, but still the model itself is just a tiny part of a production system. You still have like data ingestion, context management, data quality, very important, human judgment, error handling, all that stuff goes around it before you can put something into production. And that made me think, and this is kind of one of the key messages of the talk, so be prepared. Everyone has access to the same foundational models, basically. These models are amazing, but we all have access to them, and it's kind of easy working with them, right? They're just an API call away. You have great libraries like Pedantic AI or, for instance, LangChain, you name it. There are many of those, and it's super easy to use them. But if you really want to be successful with those, you have to build something around it. And this is where the real differentiation comes in, because this is kind of the context and operational layer. And this is where you do exactly these 4 things that I mentioned in the beginning. And yes, I also try to put it into a metaphor. This is the worst part of the presentation because I have to pronounce this correctly. And I'm not sure if there are any French-speaking people in the audience. Okay. Oh, damn, okay. I think it's like mise en place, is that correct? Mise en place? Mise en place, okay. I hope I don't have to say it again, but this is kind of the metaphor, and what it means is putting things into place. So it's like a French culinary term, and it means like if you go into a professional kitchen, of course they are not starting to prepare just then, they prepare beforehand. So once the rush hits, everything is fine, and your meals will be ready, hopefully in time. And you can do the same thing with production AI systems, right? You don't take a prototype, put it into production and say, hey, let's go. Instead, you try to build something around it, and you want to be ready before the first customer hits the system or whatever. And this is something I want to talk about today. And for that, I brought you some recipes. Now, the timing is a bit bad because we just had lunch. I was hoping to have the talk before lunch, so yeah, this would be better. But anyways, let me show you the kitchen crew for today. So first of all, we have Apache Airflow, obviously. That is the kitchen chef, so to speak. And then we also have the Airflow AI SDK preparing the dishes, which is another open source project you can check out. But a little cliffhanger, there's something new, which was actually released today, or this week actually. So this is a small cliffhanger. You have to wait to the end, and then I will reveal what it is. So stay tuned. All right, this is our menu for today. So we will start off with a very delicious customer review processing. And afterwards, I will show you the dessert, which is also delicious, decision tracing system. And I will show you how that works with Airflow and how we can make like this production ready, kind of. All right, before we do that, I'm sure you're all familiar with orchestration. I don't need to explain to you what that is or how it works. So the only thing I want to do is establish like a common terminology so that we all know what I'm talking about, right? If we are in the Airflow world, our data pipelines are called DAGs, and these are kind of the tasks and dependencies between them. We also have the task and operators. So like an operator is like a blueprint for a specific thing you want to do, like for instance, running Python code or executing an SQL query. The task is the instance of that, so the concrete usage of one of these operators. A DAG run is the execution of a pipeline. XCOM is the communication between tasks. We also have assets, so these are like named data artifacts that you can update, and these updates can trigger other DAGs. Then there's the task flow API. This just means that we use decorators for defining our tasks and DAGs. You will see that later. Human in the loop, very important for this whole use case, means that we pause the pipeline and wait for human input. I will also show you how that works. And dynamic task mapping is very specific, but also a feature I like very much. So that means that we parallelize the task execution at runtime. All right, with that in mind, we can go for the first recipe, this delicious customer review processing. Let's have a look how this looks like in Airflow. So what you see here on top is the data pipeline. So this is kind of the DAG that we have, right? And the first step in this DAG is that we get the reviews from a database. Then we do some formatting. This is boring Python data transformation, doesn't matter. But then the fun part is actually on the top right, the LLM inference itself, called analyze reviews in this case. And you see these brackets. This means that we do this in parallel, and we scale that at runtime. We then have some result that we prepare to be inserted to the database, and this is kind of the last step that we do. And what am I talking about at all? So the use case here is like an artificial interplanetary space travel company where you can book trips to Mars, Moon, and whatever. And yeah, these are customer reviews for those trips. So the input, for instance, could be that a customer, in this case 2 passengers, they booked a flight to Mars for $60,000, and they are very upset about the food because it's just this vacuum sealed, boring, whatever. So, I mean, it's fair for that price. They also attached a photo to this review, and this is kind of the input, right? The output, in this case, looks like this. So once our DAG was successful, what we get out of it is, first of all, a review summary, an image analysis. So we will also do multimodal LLM inference in this case. We also get a sentiment. It's quite obvious. I mean, this is a negative review. And also a category. So in this case, that we know which department might be interested in this kind of review. So before I jump into the details, you will see some code in a second. I want to show you this because that's quite fun. One of these side quests I was talking about in the beginning. So this is an Airflow plugin I created for this kind of use case, and it's actually having a support portal inside Airflow rendering the results of these kind of analyses inside Airflow. And if you're interested in that, since Airflow 3.1, we have these React-based and Fast API-based plugins in Airflow, and you can create them on your own. Actually, fun fact, we even have a skill in this open source repository you can check out, and it's quite amazing what it can one-shot for you, making Airflow a lot of fun, actually. So fun fact, I created a pixel art RPG game where you can run around and interact with your DAG. So if you're into gaming stuff, that's quite fun. Anyways, that's not the topic of today's presentation. Okay, let's have a look at the ingredients of our first meal. And just that you know, on the top you see the DAG, so that you always know what I'm talking about. And first of all is structured output. Very important to actually validate the output that the LLM is returning for us. So this is something I don't need to explain too much. It's just based on Pydantic, some kind of model that we expect from the LLM. The more interesting part happens right here. This is how you define a DAG in Airflow using the TaskFlow API, so with a decorator. If you decorate a function in Airflow, it becomes a DAG generator function. That means I need to call it so that the DAG is actually generated. The interesting part is the default args here, because this is something that allows you to set parameters for all the tasks within your data pipeline. So in this case, it's very easy to say, hey, whatever I do in this data pipeline, I want to have 3 retries and a retry delay of 10 seconds. There are also other settings you can set, but this way you get this reliability very easily built inside Airflow. So this is something to keep in mind. Now let's have a look how the magic happens. And this is a bit, I wouldn't say counterintuitive. Oh, sorry, good. It's not counterintuitive, but it's a bit special because the function that we call here, the Python function, is not doing the LLM inference. We use a decorator. A decorator in Python is actually a wrapper function around a function. And within this wrapper function, the LLM inference is happening. So instead, what our Python function is doing, it's preparing the context for the LLM inference. So whatever we return in our function will be passed on to the large language model. And in this case, we will return the review text and the image as binary content if there's an image attached to this particular review. And this will be passed to the LLM as context. And then the LLM inference itself is configured as parameters as part of the decorator. So here we define the model, the system prompt. I mean, it's quite clear. We want to analyze the review, and also the structured output, and a parameter that has a very long name called max active TIs per DAG run. This is actually very important for parallelization, and we set it to 2. Which means overall in our data pipeline, we only want to have 2 of these run in parallel. Keep that in mind. It will make more sense in a second when I show you how I use this. So this is now, again, zoomed out a little bit. So the function that I just explained is over here, analyze review. And now we have a look how this all plays together. Okay, so first of all, something I want to show you is this. This is how we can get the reviews from the database. It's just executing an SQL query. And what might be special here is that this is not a decorator, obviously. It's a plain old Python function or class in this case. So you can also combine classic operators together with decorators. That's not an issue at all. So Airflow comes with a ton of integrations. Some of them have decorators, some don't, but that is totally fine. As you can see on the bottom with the green arrow, we can also combine the output together with a decorated function. Now, what is more interesting is this part. And if you look at analyze review, I'm not calling the function, but I call something called expand on that function. What that does is it will create multiple instances of this task at runtime. And I think the picture explains it a little bit better. So imagine we have like 3 reviews, each with a review text and an image path. If I pass a list to the expand function, it will create one instance of the task per list item. And that way we can do the LLM inference in parallel at runtime. And now back to the long parameter name I just explained. So max active TIs per deck run. It means that we only want to have, in this case, 2 of these run in parallel. The third one is waiting for us. And this is already pretty cool because it gives us more control over the performance. Right, so as a summary, so the main dish had like 4 main ingredients for us. Structured output, very important, retries and retry delays. If you're interested, there's also more like exponential backup that you can use. The LLM inference happens just with decorators, which is pretty cool because that way it becomes like a first-class citizen of your data pipeline. And we also want to have parallelization at runtime, and this is done with expand in combination with this parameter. And if you're interested, there's a GitHub link on the bottom. So I'm not sure if the slides are shared like this. Maybe take a photo, I don't know, but you will be able to access that somehow. And this contains the project, so you can actually check it out and run. So it's really a real project that I built. Like I said, another side quest, I love those. Yeah, so check it out. Now, time for the dessert, this delicious cake. Let's have a look how this is built. In this case, we speak about support tickets. So just imagine some support ticket comes in like this. So it's just a piece of JSON, and we have a customer, we have a subject and a message priority. Very basic, right? Let's have a look at the support ticket system DAG. And what we do is we fetch a ticket. We then generate an AI response with another decorator, in this case an agent decorator. We then have a step that is fun because we have another agent rating the output of the first agent, so AI as a judge. We then do some formatting, that's boring stuff, but the interesting part is what we do with it, and that is we have a human in the loop step where our pipeline actually pauses and a human can rate the AI outputs. And finally, we have a placeholder task, the process task. Imagine we're just sending it back to the customer or something like that. So what does it look like? When we execute this, we get 4 things in total. First of all, the AI summary and the proposed response, then also judgment of that from another AI, human judgment, and decision trace, because we can use the human judgment as context, feed it back into the system, and that way improve it over time. And that is also something I will show you in a second. Now, this is how it looks like in Airflow. So basically, you have these human-in-the-loop tasks, and they stop the pipeline. Now, you can see that this is, can you read it? It says deferred. This is something that is new in Airflow 3. So basically, instead of utilizing your worker slot, this kind of task gets deferred to the triggerer component, which is something new in Airflow 3, and that will process these as async Python processes so that your system is fine, because, I mean, that will be the first thing to be worried about, that it will just utilize your worker slots forever. This is not the case because they are deferred. And this is how it looks like. So we get this nice markdown rendering of the form, and this is how the AI response could look like, for instance. Also, this is how the review of the AI by another AI could look like. And last but not least, here you see that we have also input elements where the user can input some information and also select from a series of options. All right, let's have a look at the ingredients of this delicious cake. First of all, we have the generate AI response. So this is like the first interaction. In this case, we are using an agent. And what is interesting here is that we have tool function. These are basically Python functions that we can implement. In this case, this Python function is just reading markdown files. These markdown files, I will show you in a second how they are created. These represent the human decisions from before, kind of. And we have agents. So what you should know is all this is built upon Pydantic AI. So this is like the agent class from Pydantic AI, and there you define the model, the system prompt, again, structured output, and a set of tools that this agent has access to. Yes. And also, then defining that in your data pipeline is fairly easy. You can use the agent decorator, pass the agent instance that we just created. And again, the logic is whatever we return in this function will become the context for our interaction with the agent. So in this case, we just dump the ticket as JSON. Now, human in the loop. Let's have a look how the human approval looks like in this pipeline, because this is kind of the interesting part. This is just a warning up front. This is the most complex part to use it. So I chose the most complex class just to show what is possible. The HITL operator. It has a subject and a body. The body can be just markdown. You also can have a set of options. These are mapped to the buttons and the user can decide upon. And also we have a set of params which map to these input form elements, kind of. Also, yes, there's an execution timeout, and depending on if you have a default or not, the task will either fail if you don't have a default after that time, or choose the default if you have a default set. Now, there are a few of these operators you can use. So, like I said, the base class, that is the most complex one that you can use, but also there's an entry operator that is just there for data intake. So it means it has the form inputs, but doesn't have the options. And also we have a branch operator. That is pretty cool because it's easy to use and the user can decide which branch in the data pipeline should be taken based on a set of options. And last but not least, the easiest one is the approval operator. So there we just have approve, reject, and it also affects the downstream. So if we reject, the downstream task will not be executed. All right, now we need to take a step back, so zoom out a little bit, because now I want to talk about the decision trace. So on the left-hand side, you see the DAG I just described, right? So the support ticket system DAG. But on the right-hand side, you see another DAG called the gather decision trace. This will be triggered whenever the first DAG finishes. So this is a relationship that we build via assets, and every time the first DAG finishes, the second will run. And it will then get some details from the Airflow REST API. And this is quite interesting because actually, if you use any kind of orchestrator, and if you think about it, it's also a great source for context because your orchestration layer knows when your data goes from A to B, it knows what A and B is, and it has a lot of information in it that you can use for context. And in this case, what we do is we get the most recent DAG run for this specific DAG, and we get the human in the loop details for it. And then we store it inside a markdown file. And this is then, again, read by the tool function that I showed you in the beginning. So this is where it's used. And it will then use these kind of markdown files as context so that hopefully the agent improves over time because the human decision also involves that the human inputs why a decision was made in this case. If you zoom out again, this is also something known as human in the loop with episodic memory. So there you have like a policy. This policy has a reward signal going into the experience collector that is written to a memory, and the memory is basically the episodic memory that is then going inside to the policy. And this is a nice system you can build with Airflow, for instance. And yeah, it's something that is very good because it will improve over time. Now, last but not least, just how do you interact with the Airflow REST API? Actually, I don't need to tell it to you, but just as an inspiration, it's just simply a task with some Python code and making some requests. But it's very simple, and this is what I want to show here because it has a lot of information for you and it's easy to get, and I can just encourage to use the context that you already have in your orchestration layer. So as a summary, we have tool functions, we have agents via the task.agent decorator, we have human in the loop, and we have the Airflow REST API. And yet again, this is a real project you can check out. So this is built by my colleague Tamara. So if you see that, Tamara, hi, thank you for that. And yeah, you can check it out and run it on your own. It's pretty nice and interesting to learn from. Now, the Mise en place mindset. Cool, thanks. Let's see what we learned. So what is very important is for these four aspects I showed in the beginning is that we have a certain set of tools, right? We have human in the loop, we have this native AI integration in our orchestration layer. The context that we get from the API and orchestration itself can help us to parallelize and control the flow. Now, the mindset is we want to build systems that are ready for production before we go into production, and not take like a quick AI prototype and say, yeah, that works, that's production ready, which happens these days, I heard. Yeah, and what I want to say is that models improve over time. The teams behind these models, including OpenAI, they're doing an amazing job, very impressive. But this happens, right? They improve over time. But the context and operational layer, this requires intentionality, and this is where Airflow comes in, for instance. Now, I promised to you that I have a cliffhanger, and this is something that was actually released like this week. So today there was some announcement about it. So it's perfect timing, like it was planned. The Airflow AI SDK still exists, but there's now also a common AI provider called Apache Airflow Providers Common AI that you can include in your Airflow project, and it will come with the same set of decorators. So the whole principle that I showed you is still the same. You use these decorators, but it comes with additional functionality. And one thing that I find is very impressive is that you can use any kind of hook as a tool function. And if you're not familiar with Airflow, this doesn't mean anything to you, so let me explain. So Airflow has these operators, right, for everything. And these operators under the hood are using hooks to actually perform the interaction with external systems like S3 or Snowflake or whatever, Databricks. And now you can use any of these hooks as tool functions, and that way your agents become, yeah, very powerful out of the box. You can, in this case, connect it to S3, have a SQL tool set, and ask it just to summarize revenue by region. And that makes these decorators extremely powerful because, yeah, you get like 350 plus provider hooks out of the box. And yeah, it's definitely something to check out. Like I said, today there were many blog posts on the Airflow blog that you can check, and it's really interesting. All right, and with that, I'm already at the end of this presentation, and I'm of course here for questions, but I just want to say very much thank you to the whole program committee, to everyone organizing this conference, and for you being here. And if you have no questions, I wish you a wonderful rest of the day. Thanks.